What's up guys, welcome to J.Codes. This is the first tutorial of Java. What is Java? Java is an object-oriented programming language because most of the things in Java are grouped as objects. But it's not a pure object-oriented programming language. Why? Because there are not only objects, but also primitive data types. Here are the 8 primitive data types. An int, which stands for integer. Boolean, who holds 2 values, true or false. A char stands for character. A double, which is double precise floating point number. A float, which is a single precise floating point number, which is also less precise than a double. A byte is an 8-bit version of the integer. A short is a 16-bit version of the integer. And a long is a 64-bit version of the integer. Now we're talking about size. An int is 32-bit. A boolean is unknown. A char is 16-bit. A double is 64-bit. A long is 64-bit. A short is 16-bit. A byte is 8-bit. And a float is 32-bit. How does a bit work? Here we have a sequence of binary numbers. This digit is 1 bit and its value is 1. This digit is 1 bit and its value is 0. This is an example of how to convert an 8-bit binary number to a decimal. If it's signed, we're going to apply 2's complement to it, otherwise we don't. What's signed? A signed number is positive, negative, or 0. What's unsigned? An unsigned number is positive or 0. This is an example of an unsigned binary number. A binary number is 2-based, so we leave the base as 2, raised to a power, starting from 0. Here is a more readable version of it. To convert a binary number to a decimal, we bring down the number below a 1, otherwise we leave it at 0. Then we add them together. 128 plus 32 plus 4 plus 1 is 165. Here is an example of a signed binary number. The main difference between a signed binary number and an unsigned binary number is the very last bit. An unsigned binary number has a positive number for the very last bit. A signed binary number has a negative number for the very last bit. Here is a more readable version of it. Now we convert that to a decimal. We bring down the number below a 1, otherwise we leave it at 0. And we add them together. Negative 128 plus 32 plus 4 plus 1 is negative 91. To get the maximum value of the signed number, we leave the very left bit as 0 and the rest of the bits are 1s, and we add them together to equal 127, which is also equal to 2 to the power 7 minus 1. To get the minimum value of the signed number, we leave the very left bit as 1 and the rest of them are 0s. And this will equal to negative 128, which is also equal to negative 2 to the power 7. Here we can see that in the powers place there's a 7, which is 8 minus 1. And in more general cases, for an n-bit integer, the max is 2 to the power n minus 1, and for the minimum, negative 2 to the power n minus 1. Here is an example of the value range for a long and an int. Here we compare a double versus a float. A double is a 64-bit, and float is 32-bit. For example, a double is this precise, while a float is half as precise as a double. Double is 64-bit, while a float is 32-bit, so that means a float will save more memory than a double. However, a double is much more precise than a float. Now we're going to talk about the comparison between double and float. For instance, 1 over 3 in double equals this. 1 over 3 multiplied by 1 over 3 equals 1 over 9 in double, which equals this. However, in float, 1 over 3 equals this. 1 over 3 multiplied by 1 over 3 does not equal 1 over 9 in float, which is bad, because they should be equal. Usually I will use double to avoid some very common computing errors. But is double safe to be used for very precise values? The short answer is no. But why? For example, if we put this value into a double, what results is this, which is less precise than the original value. If this happens at a bank, the user may wonder where $7,543.21 goes. So how do we deal with this? The solution is Java.math.bigdecimal. Today we have learned what is Java, what are primitive data types, what is 2's complement, how to convert a binary number to a decimal number, is it safe to use double for very precise values? Hopefully you will find your answer to these questions.